How are you?
Can you hear me?
Yeah, can you hear me?
Yeah. So how's it going?
Oh, it's sorry. Gotta fix my phone.
Oh,
It's
you're
going
good.
good.
Yeah, you understanding all this fun stuff?
Yeah, this week was actually I like using SPSS. It makes it a little bit easier.
Yeah, how'd you do on the second lesson homework last week?
I think I got 100 on it. I missed
Did
one.
you?
That's the one that had 10 questions.
Yeah, I did not do good on that, so I probably need your help on this stuff.
Okay. Well,
Because
let's
since my SPS wasn't working when we were doing it, I don't know what I was thinking. So,
Oh, okay. Okay. So what do you want to start with?
if you're cool with just going through we can just go through all the questions right quick that we're supposed to. That'd be cool, just to make sure I'm doing it right.
Okay, let me open that up. Okay.
Uh,
So the first one is about the matched pair. You understand that part?
yes. Yeah.
And then the differences between the different tests. Just that
Yeah.
on this one we're doing now, you need to calculate the difference. So we have to add the difference column in.
Right. Yeah. I figured I was doing that right. I just wanted to make sure.
Okay.
You know what I mean?
Yeah, for sure.
All right. I think I'm good on that. See, I'm trying to remember what I.
You want to look at lesson 11
Um.
and talk it through, or do you
Yeah.
think you got it
That
now?
actually probably would be good. If you're okay with that, real quick, just even the quiz.
Yeah, I'm good.
Yeah. Cool. Or not the homework, but it feels like a quiz.
Yeah. Okay.
Okay. So it turns out I don't know how to do the p-value, I guess.
Okay. So the p-value is kind of tricky because
Okay.
you have to know if it's one-sided or two-sided. Because if it's a one-sided test, you have to have that significance level result. So, um, let me think. You want to open one up and go through it, or how do you want to do it?
Um.
Like we could open one of the data up. Yeah, do you have SPSS up right now?
Yeah, I'm trying to open it right now.
Uh-oh. It's gonna
It's
give you
gonna
problems
be.
again.
Let's see. I think it'll be okay. I've been using it today. It's fine.
Okay.
So I guess, how do you know if it's one-sided or two-sided then? Because I guess I'm getting
So it depends.
mixed up with that.
Okay. So that depends on your null hypothesis. No, your alternative hypothesis.
Your alternative. Okay.
So if your alternative hypothesis is the does not equal, the equal with the slash through it, then it's two-sided because it could be either more or less, right?
Okay.
But if the question it's asking is you want to determine if there's been a decrease, then it's less than, so it's one-sided. And if it's you want to determine if there's an increase, then it's one-sided because it's only the greater than side.
Okay.
So then when you do the compare means sample t-test and you get that result, that
Mm-hmm.
the one column has the t-score, right? The
Right.
first one has the t-score. This I think it's the second column. Let me see, because I've been working on the homework for this lesson, so I should have one of them up. I'm trying to get to where I do the homework for the lesson in the same time we're doing it, so that I don't have to remember all that
Oh, that's
Saturday.
smart. I know. I don't know why I pushed. And this one, I was like scrambling to do it with like 30 minutes left
Uh,
before it says. So it was my fault this week.
yeah, that's
But
the
it's the first
worst.
time I've ever not done good on the homework, so it's kind of making me mad.
That's the worst. Okay,
Yeah,
so
for sure.
your one sample test has the t-score, and then it has the degrees of freedom, and then it says significance, and in parentheses it says two-tailed. So if it's a two-tailed test where it's equal sign and no and the slash, like right now, our null hypothesis is always standard deviation of the difference is equal 0, and then all our alternative is either um, not equal to 0, greater than 0, or less than 0, right?
Right.
So if it's the not equal to 0 one, then you use the whole result underneath that significance column. But if it's one of the other ones, you have to half it in two.
Okay.
And then that's your p-value.
Gotcha.
Maybe we'll probably have some on our homework tonight, or our quiz tonight we can go through.
Okay. Yeah, I mean,
Is your thing working?
yeah, I got it up. So if there's one that you want to look at, or
Okay, so why don't we are you good with going into the group quiz?
sure,
Okay,
that works.
let's see what it has for us today. I still have never heard anything back from the TA, so I guess we're all right.
Oh, really?
Mm-hmm.
That seems kind of weird. They only have like there's not very many more than 10 groups, right?
Yeah, I don't think so. I don't know how many
So you
classes
think
they're
they'd
doing
know
though,
by now.
but
Yeah, that's true.
I guess our recordings are good.
Yeah.
Okay, so number 3, suppose we have a set of paired data and let D equal X after minus X before. Okay. The null hypothesis is standard deviation of the difference is equal 0, and the alternative is it doesn't equal 0. So that tells us it's two-sided.
Okay.
Okay. And the population standard deviation is not known. Jordan collects a sample size of n equals 9 and computes the differences equal, the d bar equals 2.2, and standard deviation of the no.
Yeah, I need to look at those signs again too.
What is that S? Sample. Thought S was standard deviation.
I thought it was too. Is that the difference in standard? Well, no, that wouldn't make sense.
What's the value of the test statistic? What? D bar. Okay, I must be overcomplicating it because
Okay, that's the sample standard deviation.
it is the
So
sample standard deviation.
the D bar is sample mean, and that the SD bar is the sample standard deviation. At the bottom of lesson 12, it has all the signs for everything.
Okay. Okay, so D bar equals 2.2. It's 3.3. I don't remember doing something like that.
I don't either.
We did SPSS for the whole thing.
Yeah, I'm looking through the test statistics or the homework to see that, and I'm not even remembering reading that.
I guess I need to look through the textbook. Well, this is not a good start. Sheesh.
No. We'll figure it out.
Yeah.
Let's see.
I don't even open the textbook. Let me open that. Okay, 12. Okay, wait, maybe that's just as simple as, okay, hang on. Let me go back to
The test
okay.
statistic for a
It's
test involving a
D
paired.
equals X after minus X before. D bar equal SD. Standard, a sample of the differences. Can't be this hard. This is the first question.
Yeah. Let me see.
I'm thinking it's just one minus the other one.
I'm seeing it says give the test statistic and its value. Have you seen that on the notes? And it's saying the test statistic for a test involved paired data when standard deviation is unknown is a t. For this situation, the value is, and then it shows the difference minus 0. Or I need to look at. And then it has, looks like the standard deviation divided by the square root of the number. Let me see if I can screenshot this.
I just don't think it should be that hard for this first
I don't
question.
either. Are you seeing the equation that I'm talking about?
Are you in the textbook?
Yeah, I'm in the textbook.
Oh, okay, wait. Where in the textbook are you? Which section?
So there's step 4, and then there's a QQ plot, and right under it, they're showing this, how they're, it says
That's
the
the
test.
t equals negative 6.8
Yeah.
minus 0.
Yeah, I'm not sure for sure if it's it, but it says the test statistic for a test.
Okay,
But
so I was.
is this paired data though?
It should be because it said it was 9 people, right?
Yeah, and it says suppose we have a set of paired data.
Yeah, so it's like the post-test minus the pre-test result.
Right. So I think it'd be the
That's what I was
difference
thinking.
minus 0 over
Come in.
3.3 divided by the square root of 9. I could be wrong though.
Okay, girls, what do y'all want? I'm doing my meeting.
We wanted to ask if you will help us make a grilled cheese sandwich later.
Y'all have to go out of here right now so I can do my meeting. Love y'all. Okay, t minus 6.8. So ours would be t minus, it would be minus, oh, I see what you're saying.
So is it 2.2
So yeah, it would be 2.2
minus 0, right? I'm not sure where they got the 0, but
yeah, where's the actual formula for that? I guess that was from our previous lesson, I guess, when we did
yeah,
our
it must have
t
been,
minus
huh?
something. Let me look back at 11 real quick.
Okay.
Okay, so it was x bar minus the mu, which I guess is, we're saying is 0. So yeah, that's what it would be. So it's the, hey babe, all right, so if you look at the formula, then I'll look at the, so it's d bar is 2.2, and then our s is 3.3, and the square root of 9.
Yeah, so just divided by 3.
Yeah. They didn't have us do that. That was tricky. They didn't have us do that in our
Yeah, what's up
lesson.
with that?
Sheesh. Oh well.
That's not right.
Get my calculator. I don't know, why do they have you do -0? Because nothing's going to change then, right?
Yeah.
Divided by 3.3. Okay, what did you get?
I got 2.
You got 2?
Yeah,
Like just a 2?
just the 2.
I must have done
What,
something wrong. I got
what'd
0.2,
you?
0.222222222.
Oh no. Okay. So what's 3.3 divided by 3? So 1.1 and then 2.2 divided by 1.1 equals
It's
2.
2. Okay, so let me look at what I did wrong. Okay.
And I think 4 kind of shows that it might be right because it says the probability of being greater than 2 is 0.0403.
2.2 divided by. Yeah, now I got 2. Okay. I just
Okay,
did
cool.
yeah, okay.
Yeah, it can be
So
hard on a computer.
I guess we'll just put a 2 because it didn't ask
Yeah,
for
it doesn't
any
say anything
decimal
about
points.
right.
The probability of being greater than 2.0 is 0.0403. Use HA to determine the p-value for this test.
So HA's can't be equal to 0. So what do we have to do?
The probability of being greater than 2.0. So the p-value is 0.0403. They're saying the probability, isn't that? Okay. I don't know. Maybe I'm not getting it.
This is probably where I'm screwed up, so I might not be the
The
best person.
probability of being greater than 2.0. Wow.
Do we have to use the applet?
I don't think so, because that's for
That's for something completely different.
determining the p-value, but what's when you know the standard deviation?
Mm.
Because we know what our sample deviation. No, I don't think so. Probability.
Okay.
None of our questions on the preparation assignment are like this.
Ever on this, right?
Not at all. Sample sizing.
That's all. I don't remember seeing it in either of the videos either.
We don't have all the data to be able to. Okay. The probability of being greater than 2.0. I have no idea. Let me look at the textbook real quick.
Okay.
Probability. Mark the test statistic. Okay, so the next thing after what we just did says mark the test statistic and p-value on a graph of the sampling distribution. So they took the result, which was there for them negative 11.145, put it on the distribution. Please not this image. The statistic was find the p-value and compare it to the level of significance. So they took 1.0. Where'd they get 1.06 from? All right, let me go to the applet and see what I get when I put in that negative 11.145.
Okay.
See if we get the same thing they're getting so we understand what they're doing.
Let's see.
Come on. Okay. Negative 11.145. No. The numbers up in the area are not 1.06.
Where are
So
they getting? Because I'm looking to see where they're getting that too. Let's see.
The test statistic T is labeled on the horizontal axis. The p-value is the area to the left of T under the curve. So ours was 2, right? So if I put 2 in there just to see what we get, ours was positive 2. And we just want the area to the right of that then? Or do we want both since it's does not equal? What was their alternative hypothesis? Yeah, theirs is a one-sided test. Ours is two-sided, so I guess we would need both areas.
Okay.
It says 0.0455. So I guess we can go with that.
That works for me.
That's what it says in area.
0.0.
It's 0. Okay, hang on. Let me look at it. 0.0455. So 3 decimals would be 0.046.
Okay. And that's the p-value, right? Because you can find the p-value using the applet.
Yeah, that's the p-value up in the top of the applet.
Okay. That should be good then.
We're gonna take that as what they want, and then I guess we'll see and fix it in our homework if we need to. Okay, use the data file, chapter 12, data A. Okay. Okay, so first thing we should have to do is to make the differences column, but let me see what it says. To answer 5 through 10, make a column of differences. So you know how to do that?
Yeah, I remember how to do that.
Go to transform, compute variable, differences, and then we don't know what each one is. We don't know which one is pre and which one's post. I guess, why don't we do group 2 minus group 1?
Okay. What was it? Chapter 12, data 1?
A.
Data A. Okay.
I think I have too much stuff open. I'm like, where am I?
I know.
Okay, that says chapter 12, data 1. Okay. Then we need to analyze. I just do it all and then look for the stuff. So analyze, and then what I do? Analyze, descriptive statistics, explore, differences.
So what'd you name group 1?
I left it group 1, but
okay.
I put differences on the side for the name of the new column.
So group 1 minus group 2, right?
No, group 2 minus group 1.
Group 1, okay. Let me start over.
Because group 2 is probably like a post test.
Gotcha.
Sorry, I'm moving so slow on this. And you're good. You're good. You're good.
So analyze and then descriptive statistics?
Yes.
Okay.
That's what the man in the video always does, so that's what I do.
And he does frequencies, right?
He does, let me begin. Analyze, descriptive statistics, and then explore.
Oh, explore, okay.
And then you'll put differences under the dependent list.
Okay.
And then go to plots on the side and select histogram and QQ plot. Or it doesn't say QQ, it says normality plot with tests.
I'm not even. It doesn't even have that one for me.
Okay, tell me where you are.
Well, I hit histogram, but it doesn't have the normality one. Oh, there it is. Never
Underneath,
mind.
yes,
Yeah,
it's
I'm
not in the
lying
same
to you.
section. That's okay.
I'm lying. Okay.
And then hit
And you-
OK.
Okay, cool.
And then once that goes to your output, then you want to go to analyze again,
Okay.
compare means, and then one sample t-test, and move differences over as your test variable, and then hit OK.
All right. So is the difference that's like the mean of the difference column, right?
The D bar?
Yeah, the D bar.
I think so. I'm looking at the text right now. D bar, sample mean, yeah. Okay, so we're going to go to our output, and our sample mean, see where it says one sample statistics at the bottom of everything we just pulled?
Let me see. Like on the little sheet that gives all the information.
Uh-huh. So the last, at the very bottom of that, the last thing you should have is one sample
Where it
test
says,
box.
yeah, the t-test
And then right
one.
above that, it says one sample statistics.
Right.
So the mean right there, that's the mean of the differences, which is negative 31.0250.
Okay.
It's pretty high for
That is really high.
the mean. Okay, so round to 3 decimal places. So we have negative 31 point.
025.
I didn't write it down. 025, yeah. Okay, and then standard deviation of the differences is 341. Wow, 341.157.
All right.
341.157. And then you can also check on your histogram. On the side, it has that the mean, standard deviation, and n. So you can see there that that's the right numbers.
Gotcha.
Okay. What's the test statistics? So that on the output, that is our t-score, which I have negative 0.407. Is that what you have?
Yeah, that's what I have.
All right, so negative, whoops,
407.
0.407. Okay, negative 0.407. Okay, and then our p-value, let's go back and make sure on our null hypothesis, alternative hypothesis does not equal. So that means it's two-sided. So our p-value is where it says significance, two-tailed, so it's 0.689. 0.689. So we fail to reject, right? Because 0.689 is a lot higher than 0.10.
Yep.
Okay. Suppose your alternative hypothesis is greater than 0. What is the correct decision based on this evidence? So if it was one-sided, then we would take 0.689, which was our p-value, and divide it by 2, which would still give us
Right, so it'd be less.
0.34 or something. So we would
Yeah,
still
so
fail
still
to
bigger.
reject.
Right.
Okay, now open data B. Okay, then transform. Okay, so we'll do group 2 minus group 1 again.
Okay.
Keep it consistent. Okay, let me know when you're ready or if you get stuck.
I think I got it.
All right, so it says our null hypothesis, of course, is equal 0. Which is greater, N or DF? So our N is, well, N is always greater because DF is N minus 1, right?
Yeah, I mean, and even when you look, wait, that's the other one.
They're trying to trick us.
Yeah.
The
Yeah, N
formula
should
for
be
DF
bigger.
is N minus 1, so N is always going to be greater. Your alternative hypothesis is does not equal 0, and you use a level of significance of 0.01. What is the p-value? Okay, so our p-value is 0.001. Is that what you got?
I'm looking because when I compute it, it's showing the data for the A and the B still. So I'm trying to find.
Yeah, you have to go to the bottom of the scroll bar.
Oh, it
It
just
puts your
goes
new
to the
stuff at the
bottom.
bottom.
Oh, okay. Yep, that's what I got.
All right, so we got 0.001. So that means we would reject because 0.001 is less than 0.01, right?
Yep.
Okay. You decide to try another alternative hypothesis. This time you use greater than 0 and you keep the same level of significance. Oh, wait. Is that right? Okay. Did the p-value increase or decrease? 0.001 divided by 2 would decrease
Yeah,
the
for sure.
p-value, right?
Yeah.
So you're going to half it.
So you still reject.
So it would be like 0.0005.
Right.
Or something. So we would still reject the null hypothesis. As we've seen, the p-value depends on the alternative hypothesis. Setting aside the data in this problem, do you think a general rule can be made? Which alternative hypothesis will give the smallest p-value? Smallest p-value.
Seems like the greater has made the smallest p-value.
The smallest p-value.
Because in
Well,
the greater one, isn't that where we would have divided it by 2? And it's 0.005.
the first one that's on there, the not equal to, is the highest because that's the two-sided.
Right.
Then we divide in half for the other two. So which alternative hypothesis will give the smallest p-value? Because greater than or less than would have the same p-value.
Right.
And not equal to is double the other two. So I'm thinking maybe not enough information, depends on the problem.
Yeah, that's probably true, huh?
Because it wouldn't be any of the other three.
Right.
I don't know, that may be wrong, but I don't think
No,
that,
I think you're right.
I don't think the other ones are right. Determine the 95% confidence interval for the mean difference between the two groups. What is the lower bound? Okay, so on our output, the lower level is negative 18.6065. Is that what you get?
Let me look again right quick. Right. All right, say again what you got.
Negative 18.6065.
Yep.
Now it doesn't tell us how many decimal places to use on that, so I don't know what we're supposed to do for that. I don't want to round it and then have it be wrong. But I think in general we do the 3 decimal places, right?
Yeah, I think that's what it says. So 607 would probably be best.
607. Okay, we're gonna go with it. And then upper value, I had negative 5 something. I don't remember.
Yeah, where is
Negative
that one?
5.303.
Yep.
Negative 5.3. Oh, okay. Make sure we answered everything. I think we did. All right, ready to submit?
I am ready.
95.
95? All
Yep.
right, what did we miss?
The probability one. The probability of being greater than 2. The one that we put we used the applet on.
The one that we didn't really know. Huh.
Yeah.
I just wish they would give you the answer so you could work out a few different things and
Yeah,
see what you.
I have to email her and ask her, but I don't even remember them talking about this.
The probability of being greater.
The only other
That's
thing I can
probably
think
like-
of is that it should have been 0.040 like they already had in the answer. I mean, p-values are probability.
Right. Yeah, I don't know.
Being greater than. Use greater than 2 is 0.0403. I don't know. I don't get that one. I'm gonna ask her and then I'll put you on the email and we'll see what she says.
Okay,
But
cool.
I'll take a 95.
Oh, heck yeah, I'll take a 95 all day.
We
No
have a test
doubt.
coming up again pretty soon too, I think. Week 8, I
Do
think we
we?
have our next test, yeah.
Well, thanks for going over this stuff with me. It makes a lot more sense now. So
Yeah, sure. Yes,
appreciate
next
it.
week we have review and then the week after is our next exam.
Oh man.
Yeah. Okay.
I think you'll be all right though.
I think we'll be all right. We'll do another hopefully we have another page of notes we can use for that one.
Yeah.
Oh, wait, maybe. No, the exam is next week.
Oh, it's next week?
Yes, it's the second part of next week. And it doesn't say, is that right? Yeah, lesson 15, that's next week. And it's not open yet for me to know if we can have the one page. So I'll work on that a little bit if we can use it.
Sweet.
All right. Well, I'll talk to you Thursday.
Sounds good.
Thanks.
No problem. See ya. Oh, I'll post this too. Just so you know.
Okay, thanks.
All right, no
Bye.
problem. All right, see ya.